Welcome to the video from Chapter 8 Quadrilaterals. This is Lesson 1, more about quadrilaterals. The essential question we should be able to answer by the end is how do we identify, name, and solve quadrilateral problems? First, what is a quadrilateral? A quadrilateral is a closed, flat, geometric figure with 4 sides and 4 vertices. Some examples include a rectangle, maybe looking shape, something that might look like a square. It is closed, all the sides are meeting. Even this is an example of a quadrilateral, 1, 2, 3, 4. Maybe that could be a little closer together, same thing here. But any 4 sides does not have to be parallel, does not have to be any certain angle measures in there, but they need to be 4 sides that all connect together in one closed shape. Unlike this non-example, and this doesn't work because this is 3 sides, this has more than 4 sides, this has a rounded side, but if you look at this shape here, this has 4 sides, 1, 2, 3, 4, or at least 4 lines created this figure, but it's not a closed geometric shape that has this extra vertex here, so there's just way too much going on. This is not a quadrilateral. When we name a quadrilateral, we name it in order, clockwise or counterclockwise. It does not matter which direction you go, and so therefore there are always options. Now when we actually write the name, we may just be able to use the word quad to represent quadrilateral. Notice that I started with A simply because alphabetical order, A, B, C, D, so these are clockwise examples. I did it again with the word quad, starting at B this time, B, C, D, A. And then I also wanted to show 2 examples, maybe using this shape of a quadrilateral here. It looks kind of like a parallelogram. And then just starting with the next vertex, C, D, oh, that one is wrong. C, D, A, B is gonna have to be that one. So I will change that. Okay, so this needs to be C, D, A, B in order to follow consistently clockwise around the quadrilateral. And then the last one, D, A, B, C, again going clockwise. Now just keep in mind that all of these also could go backwards. So it could be D, C, B, A, D, C, B, B, A, D, C, and C, B, A, D. So there are lots of choices, but you like this one that I had first, C, D, B, A, is not a choice for this particular quadrilateral. C, D, B, A. See how my arrow went across, diagonally across the quadrilateral? It needs to go around it like a clock, clockwise or counterclockwise, not diagonal across it. There are certain pieces to quadrilaterals, so let's go ahead and identify what some consecutive angles, non-consecutive angles, consecutive sides, non-consecutive sides, and diagonals are. So using the quadrilateral QRTS as an example, the consecutive angles, those are the angles that are next to each other. Q and R would be consecutive, R and T and S, and angle Q and S would be the ones next to each other. Those are consecutive, and they are paired like that. Q and R are next to each other, R and T are next to each other, and so on. Non-consecutive angles, and remember that the angles and the vertices, like when we have something a simple diagram like this, that's really saying the same thing. So the non-consecutive would be, well, S and R are opposite of each other. Notice how non-consecutive is also opposite, specifically in a quadrilateral. It's straight across from it. So S and R are non-consecutive or opposite, and Q, T are non-consecutive opposite. Consecutive sides, still dealing with that same idea that consecutive means next to. They're going to share an endpoint. So when you pair them, they should each have a pair of letters that match. So QS and QR are both, they share the endpoint Q. QR and RT share the endpoint of R. RT and TS share the endpoint T, and TS and QS share the endpoint S. And again, this is just coming from this diagram over here. So the non-consecutive sides, again, just meaning opposite. Opposite of QR is ST, opposite of QS is RT. Last but not least are the diagonals. They're the ones connecting opposite angles. So S to R would be a diagonal, QT would be a diagonal. Keep in mind that diagonals may or may not be drawn inside the quadrilateral. That's why I put them dashed here, but they could be solid lines. It doesn't change the fact that QRTS is a quadrilateral. It just means that the diagonals are drawn as segments. Now that we know some of the pieces of a quadrilateral and how to name it, let's talk about a theorem from the quadrilaterals. And the theorem states that in a quadrilateral, the sum of the measures of the interior angles is 360 degrees. And that is important to understand because this is comparing it to a triangle which has 180 degrees. Now we're going to have the quadrilateral has 360 degrees. So mathematically, as an equation, the four angles added together, the four angle measures added together will equal 360 degrees. Of course, just like we've seen over and over again, this will end up giving us an equation we can use to solve missing pieces, missing angle measures, or maybe for a missing value of a variable. So let's jump right into an example like that. This example, we look at, it says find the missing angle measures. We look at the angle measures. We only have one variable. It is in two different places. We have two known angles, and then that variable shows up in two different places. But because we do have information in all four angles, we can add all four of them together, 80 plus 115 plus 2x plus x. Those four angles together add to equal 360 degrees. So we can simplify that by combining like terms. 2x plus x is 3x. The 80 plus 115 is 195. And so that was just a real quick combining like terms. Now I'm going to start solving by subtracting 195 from both sides. 3x equals 165. And then we can divide both sides by 3 to get x equals 55. Now, we have to, as always, make sure that we are actually answering the question that is being asked. This says to find the missing angle measures. It just so happens that x is an angle measure. So we did find the measure of this angle is 55. And then we just need to multiply it by 2 to get 110 degrees here for the 2x angle. Just keep in mind, guys, that it's always a good idea, especially when we have missing angle measures like this and two of them that are missing, to go back through and actually add those values together and make sure that they equal 360 degrees in this case. So just in your calculator, adding 80 plus 110 plus 55 plus 115, a quick check in your calculator to make sure that those do all add up to 360, and that was a quick check to make sure that you've solved for x correctly. This last example does not have a quadrilateral drawn for you, but you are, of course, always able to do that. And this is why the naming is so important. This says quadrilateral RSTU, which means it doesn't matter what sort of quadrilateral you draw. You can draw something that looks like a square all the time, or you can draw something that looks like a parallelogram or a rectangle or a trapezoid. It doesn't matter. But the point is that wherever you start, and I just always start in the top left, you just need to make sure that you go clockwise or counterclockwise around the object. You cannot go RS and then put the T down here and then the U. It's RSTU or it's RSTU. And again, you could start at any vertex to do that as long as you are going around and not diagonally across when you are drawing this shape. And that's just a helpful tool if you want to draw them, because they give us information about the four angles. You could probably get away maybe with not drawing anything to begin with, but I like to draw. And so I'm going to label the angle measure information that is given to me to just have a visual representation of where these angle measures are. But in order to actually find the measure of each of these angles, I'm just going to add them together, x plus 10 plus x plus 30 plus 50, and setting them equal to 360 and solving. Solving this, we got x equals 90. So if I go back through, this angle happens to be the right angle in there, but this would be 110. That's the 50 that's already there, and then this would be 120 degrees. And so the missing angle measures, I just went ahead and labeled in my picture. Your other option would be to write it all out. The measure of angle R equals 90 degrees. The measure of angle S equals 110 degrees. And the measure of angle T is equal to 120 degrees. And that concludes today's lesson on quadrilaterals. So how do we identify, name, and solve quadrilateral problems? Well, quadrilaterals have 4 sides and 4 vertices. They are named in the order of their vertices, and their angles add up to 360 degrees.